How's it going, everyone? Welcome. I'm Oliver Gonzalez, you know. Now, I want to make a quick recap of this particularly tools part of our toolbox that React gave us to solve specific problems. So, the TLDR of this is React allows us to write is user interface. When you now hold specific piece of information and you want to sync that with different UIs, right? So because traditionally doing this involve is a different way of doing that. So an MVC pattern, and you may wonder why we did that kind of stuff. Well, there's a lot of developers, software engineers, and people involved, women, men's, and the like, that now they come up with this thing, this process of how can we now architecture web applications or this kind of application when you have now a client and a server, right? And that is the MVC, the model view controller, because this model is where the data live, and because this data can be in different views. So you started to see the issue here. So you must be well aware of what UIs or view needs to be updated, right, properly, so you know somehow is to keep track of that piece of data that live across different views. And you have to do that using your mind. Okay, so React say no. The R&D team say no. We don't want to do that. We want is now the machine help us to do this, to keep track of that. First, the information, the piece of data, the state, and then which components now are using that, right? Read or write, okay? And then we're going to notify them. That's interesting because this is somehow is following is this event-driven approach, which is something similar of what now, for example, when you use now the add event listener or remove event listener on your browser, it's now the browser that is internally hold a data structure, a way to how not keep track of this information, this event, and all of these functions that you want to run, right? And this now whole is an internal registry here. So this is the power of this computer, bro. You know, it's like, hey, help me now here to do pretty basic stuff, which is keep track of my resources. I actually do this, for example, with my time. Anytime that I want to, or that I need to dedicate certain an X amount of time to a specific task or to a specific stuff, I now schedule this a time for that. And this is also something that you can use to schedule is now or to keep track another kind of research. So I'm mentioning is here in my case, personal case is my time, right? Which of course is French toast finite. And the other is now the things like food, water, pretty basic stuff. Some of them might call them mundane, all right? But they are needed. You need to keep track of that. You need to somehow if you have enough food, if you have protein, carbs, fats, if you consume that, because now your body will need that in order to learn something or run a marathon, or if you're an athlete or an artist or an engineering or any people that do a particular activity, you need that kind of energy. So if you are now more conscious about that and keep track of this, so then you're starting to have more interesting problems or better problems. Okay? So now food, shelter, and waters are not that kind of issues. Now you're starting to think about more these abstract and yet relevant problems. So, for example, what am I doing the thing that I'm doing, and what is the destination that I want to reach? In my case, is that looking at this particular course is to I don't need to look at this thing at all, or at least just to keep up that anytime a new version as is released. And that's it. But by understanding is the fundamental, and also reading the docs and get yourself familiar to the more you expose to this and you understand this, the better off will be for your self, you from the future. Okay, so here we are. All right. Now, what does it mean, right? Okay. So what does it mean is that now I can finally describe is this specific tool on React, right? Again, a TLDR is that React allows us to sync a piece of state across different UI, right? And that's great. I also look at how to do that, what React is doing, what is the entire infrastructure requires to do that, and the subtle different nuance. And this is great for building now user interfaces in a component-like way. But sometimes we don't want that. We also want is to deal some logic, business logic, right? And for those cases, because the only tool that we have was components or building this user interface, even though that we don't return any of these DOM elements, right? Now we have is this tool called hooks that again solve specific problems. So for example, use ID is when you have a global registry that React is keep track of that, which is useful for labels or label or attach now a label to an input in a form, especially if you have now for an onboarding process, right? You have a lot of you want to collect multiple different kind of data from your user. This is something that you see a lot of the time in financial or any other service that requires you an onboarding. All right. Hey, I didn't need to collect this data and somehow is store and manage your account, right? So traders or broker accounts, fintech accounts, bank accounts, right? That's great. I really love that, at least for the technical aspect. And so yeah, another hook is and also understand how this hook behave. What is the rule of these hooks? So always put your hooks at the top of your components, and don't get funny about this by putting inside of an if statement or in a for. No. Make them static, aka lexical. Define them only in one place, and don't add control structure to this. So, and another hooks, which is useRef, when you want to now grab a specific DOM element, you can also store here is objects, arrays, or primitive JavaScript values or objects, right? But most of the time, this is used for holding a reference of an element and then do something with it. For example, focus this element when this component is mounted. All right. Yeah, that's most the common example there. or when you want to grab now is an audio or video tag and to play or stop this. For example, this is a good example here, right? So now you can listen to this or stop, right? So this is a good way of how you can actually grab that piece of elements and then now interact in the React way. However, and because sometimes, because I'm using is another hook called useState to keep track of the data, to remember a piece of state, a piece of information over time. I also look at how these things work, the behavior, and yeah, I also Let me be straightforward from this moment on. I don't wanna do all of this stuff. So I also look at this useState, which allows to remember piece of information. It relies on closures in JavaScript, and now it involves is in a particular thing that I call core loop, that anytime that this piece of information change, so React now will detect which component triggers that and update that, generating is a new snapshot of that state, of that component, which is creating is this virtual DOM that through a different algorithm, which is a fancy way to say it's a sequence of tests, it's a sequence of steps to spot the difference among different snapshots, all right? And then apply the bare minimum necessary DOM updates to the DOM, so that when the browser detects those changes, it will now paint that to match the UI. So, because anytime that you now update that particular state, right? React behind the scenes is now creating is a new space in memory on the heap, usually, right? Which is how now the JavaScript engine store things and allocate. This is now the part of the anatomy of JavaScript engine that asks to the browser, which is this application that live on the OS, and requests space for holding this piece of information in memory and the RAM. So things started to make a lot of sense here. so when you use now this useState, that's exactly what it's doing. So anytime that you now set that state, I would like to know if this is true, my friend. Right? Let me, in fact, because this is now getting into the deep of React. Okay. It is safe to say that React.useState, when it is called, it reserve space when it is called with primitive. The JavaScript engines exactly reserve space in memory through the call stack, right? And when it does with an object, it uses the heap please provide the link where when this is true from the GitHub code. Alright, because now I'm about to get into the internals of React. Holy moly. I'm about to get into the internals of React. How JavaScript handles memory allocation for primitive versus object to verify this claim. Yeah, but I wanna check at where in the piece of code on GitHub it actually does that. So yeah, if the intuition is correct, so React, which is JavaScript code, now somehow when you pass now some primitive value, it of course going to store now on the call stack. And when you pass now an object, right, and this object now live is on the heap, which is where now JavaScript engine store objects, all right, it is stored now as in a particular memory address, right? You can think of this memory address like a specific bucket that you have in your code, right? You have left and right upper pockets. You do a winter walk, and left and right bottom pocket, right? So it can now, you can now put things in one of those places. So that's interesting in order to know this subtle difference. Because when I did this, when you understand now this process, especially when you now want to hold some piece of information and React want to keep track of that, and if you want to now create, that makes a lot of sense. And when you want to now is store now object to describe something, okay, this is held in a heap. And if you want to now spot the difference between objects, which is like property key values, right? So you have to walk, one way to do that is to walk through each one of those elements, right, and spot the difference and update that specific thing. That lookup process takes time, and there are algorithms to do so. But the other is to now recreate is a new state of that, aka reserve an additional space in memory for that. And the older reference, as long as you don't point that or you don't remember, so now the garbage collector, which is a specific part of the JavaScript engines that say, hey, now I flagged this space in memory, similar like you have housing lots, right? So now this lot is ready to be used, right? React useState implementation live in two key files. The public API in the React hooks is surprisingly minimal because it say this. And the real implementation live in React Fiber hooks, where the mount state functions handles the initial rendering. For example, this, the mount state, which is now here. Okay. So you can pass me is or a function or a particular state. And here say mount work in progress hook, right? If the initial state of different is a function, so let me now call that function lazy initialization. And then you say, hey, hook.memoize state, okay, it'll be now the base state, which is equal to the initial state, right? So the initial state, whatever value that you have, it will be now the base state and the memoize state. And then have now a queue to that, which is pending, lanes, dispatch, last rendering reducer, last rendering state. And also you have now this thing called hook the queue, right? As the queue, and the GitHub link. Notice the critical detail of the hook memoize is equal to the initial state. Store any value directly, right? The hook type definition confirms this with the memoize state here. React makes zero distinction between primitive and object values at the storage level. So how React actually stores state in memory? React Fibers architecture store all hooks as a single linked list. This is this is why data structure is important for you to understand that and to create that, right? A single linked list attached to each component's fiber nodes, right? How hooks works, how React works. When you use multiple hooks, for example here, it's a storage location fiber memoize state, which a hook is a memoize state is 0. And then if you call another one, it's a hook.next, which is the hook 2. This is the memoize state. And if you enter the use effect, this is another hook, right? And the effect object here. Every hook object is a JavaScript object living in the heap. The fiber node itself is a heap allocated. The fiber. So the fiber is now a heap allocated. The linked list of hook is heap allocated. Your state value, whether 42 or an object, right, becomes a property of these heap objects. This is why hooks must be called in the same order every render. React traverse, okay, it's because they have now a linked list where now it has the hook and the value and another hook and another value and another hook and another value, right? But it doesn't have a distinct way to uniquely identify that. So it doesn't keep track of this. I mean, it doesn't know the order of this, right? It keeps track of this, but not in order. Why the stack versus heap claim is wrong for React? The statement primitive goes to call stack objects goes to heap is a pedagogical simplification that doesn't reflect actual JavaScript behavior, especially in React context. What VA actually does with primitive is small integers stored inline using pointing tagging, no separation allocation at all, floating point numbers, heap allocated as boxes here, string always heap allocated, even hello live on the heap, heap allocated as a special oddballs object. The code stack store function execution context stack frame, not general purpose data storage. When a function return it is a stack frame is destroyed. This is precisely why React cannot use the stack for state. State must persist across render, which means it must survive beyond the function call and is created. Exactly. So it's using now some memoization, some techniques to remember that, which is a closure. Closures break the simple model entirely. React uses state return a set state function that close over internal React state, internal variable. Any variable captured by a closure must persist in heap memory because the closure outlives the function that creates it. React conciliar maintains reference to your state value across multiple render cycles. Through this heap allocated fiber structure, the real primitive versus object different in React. The behavioral difference user observed between primitive and object say come from JavaScript equality semantics. Not okay. The behavioral difference users observed between primitive and object says come from the JavaScript equality semantics. Exactly, not memory allocation. So if you compare this to this one, they are not the same, right? Object.is phi and phi is equal to true. But if you compare now two different objects, which is compare based on its identity, that's what it is. React use object.is to compare previous and new state. Two primitive values with the same content are equal. Two objects are only equal if they have the same reference. This is pure JavaScript value semantics. That's right. React doesn't special case anything. Correcting the mental model. A more accurate understanding is that React state storage is entirely heap based. So in other words, it's relying on how the JavaScript engine is storing things, and I'm going to look at that. Fiber nodes, hooks, objects, and the linked list connecting them all in a heap memory managed by VH garbage collector. The JavaScript call stack hold execution context. A local variable within a function may reference the heap data, but the stack itself isn't for persistent storage. Most primitives are heap allocated anyway. Only small integers get a special treatment through V8 pointer tagging. Median, string, floats, booleans, and other primitives live on the heap. And user state behavior. Okay. So depend on the specific JavaScript value. Numbers have a special treatment and depend on the engine. So numbers have a special treatment, but most of them are stored on the heap, right? The thing here, or the confusion, is that how these values are compared. And this is when you get more philosophical here. Okay. User state behavior is identical for all value type. The value goes into the hook memoized state, period. The only runtime difference is how object.is compare values during update bailout checks. Stable tag version here. The user understanding conflate two separate concepts. JavaScript simplify primitive value versus object by reference. Model explain copy semantics, but it doesn't describe actual memory allocation. Okay. Copy semantics or value comparison, not memory allocation. In React cases specifically, all useState values end up stored identically in the heap allocated. Fiber data structure. So if I now dig in here, all right. If I now dig in here on the React hook, use context, use state, which is a pretty simple stuff here. It called now the resolve dispatcher, which this resolve dispatcher here, it now has this, an internal identifier called React shares internals, and H. If you're in the development mode, this is it. Invalid hook call. Hook can only be called inside of the body of a function component. This could happen for will result in a null access error if access outside of the render phase. React share internal. If the dispatcher is null, it means that it's outside of the component, React component. Okay, and then it's gonna return is now with this dispatcher here. React conciliar, React internal types. And this dispatcher will have now is this particularly hooks. So if you dig in here, right inside of this dispatcher, React internal types, specifically the dispatcher, here you have now all of these different hooks. Oh my god, you're starting to look at the anatomy of this S. Holy hell. So is this dispatcher here, and they call dispatchers React internal types, and when circular move from React fiber hooks to all. So all of these different hooks here. Use state, use reducer, use context, use ref, use effect event, use insertion effect, use layout effect, use callback, use memo, use imperative handle, use debug value, use defer value, use transition. Use sync external store, use ID, use catch refresh, and so on and so forth. Right? Okay. Alright. And it's interesting. A fiber is work on a component that needs to be done or was done. There can be more than one per component, but it's a work on a component. What is the tag of this work? The key, the element type here, work type here. A queue of state updates and callback. The state used to create the output memoizes state. Dependency, context, and events for this fiber, and it has been any dependencies. Bit field that describe property about the fiber and it is subtree. The concurrent mode flag indicates whether the subtree should be async by default. When a fiber is created, it is inherited the mode of its pattern. Additional flag can be set at the creation time, but after that the value should remain unchanged through a fiber lifetime. Lanes and child lanes. Alternate actual start point. So this is the work. So it called fibers, right? A work on a component that needs to be done or was done. What? And if you take a look at the tag, work tag, right? React word tags, React word tags, React word tags. Here it has it's pretty simple. It's pretty simple. They didn't I laugh I laugh because it say, hey, oh, this is 0 or 1 or 2 or 3. You know, they have a very specific things to do, right? So you have all of this work tag, and you say, hey, is the work needs to be at the function component, or it needs to be at the class component? What is the host root or portal or component or host text, fragment, mode, context, consumer, context provider, forward ref, profiler, suspense, memo, simply memo component, lazy component, incomplete class component, dehydrated fragment, suspend list component, scope component, off-screen components, legacy hidden components, catch components, tracing market components, hostable, host singleton, incomplete function component, throw, view transition activity, and activity component. So this is all the work that it can be done in a component. Interesting. And they say, hey, you know what? Who's to blame for this? 10 years ago. Yeah, they add a new, you see, holy fuck. They add that, god damn it, 10 years ago. That's a lot. Code Mom. They have worked directly with them. That's interesting. Okay. My respect, sir. My respects, sir. Okay. Okay. Okay, my respects, sir. My respects, sir. Okay, so I'm starting to understand this. Right. Right. Okay, this is the word tags. So the word tags is indicating is what is the specific word that this component needs to do, or it was done, or was done exactly. Okay. And then since this is the React internals, let me go here a little bit. Right. This is React word tags. React word tags. Exactly. React word tags. And now here, React internal types. Okay, there you got it. React internal types. React internal type is this. Okay. All right. Okay. Okay. So according to you, now when you look at this on mount state, it's gonna keep track of that memoized state, but based on this hook, on the mount state. On the mount state, there is no mount here because it's on the React hooks. This is part of the hooks, and what these hooks are doing behind the scenes. This is the React fibers here. That now you can look at this mount effect instance. So on mount here, mount hook type def. Mount work in progress hook. You have this hook with the memoized state, base queue, and the queue here. Okay, so it's gonna use now a queue for to keep track of that particular state that needs to be memoized, the base state and the base queue. So I need to know how to create a queue. Okay. This is a couple of things that I know that I have to do. I need to know how to create a queue. Makes sense. I need to know how to create a queue and a stack for this. All right. Good. Perfect. But it all makes a lot of sense. But it all makes a ton of sense of what React is doing behind the scenes with that particular state hook. And now with this effect that is running this function after every renders. And we need to do this to sync our state with the React, all right, app and an external system, whether it's part of the web APIs, navigation, So navigation or so navigation or canvas or local storage or storage or listen to events, right? Which is managing global state, timers, fetching data. Hmm. Mm-hmm. 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 And why do we have this thing called strict modes? React support custom hook. This means that in addition to the hooks that come with React, like useState and useEffects, amongst others, we can create our own hooks. Things like use interval or use on scroll. Custom hooks are the best things about React hooks. They make the entire API shine. And honestly, I have been anxiously waiting for us to reach to this point of the course so that I could share them with you. If you have been struggling to understand why people like hooks, hopefully this lesson will make it clear. Not scary as it sounds. The first things to understand is that we aren't really inventing our own hooks. When I first heard the term custom hooks, it sounded intimidating, like something only that most advanced power users will use. Hooks are hard enough when we use the default one. The light bulb moment for me came when I started thinking of them as custom hooks combos.
So it's finally time for us to talk about custom hooks, and oh boy am I excited. This is my favorite part of modern React, and honestly it's the thing that finally got me to feel like hooks were really worth all the trouble. Like, I know that this module has been tricky at times, and useEffect just feels way more complicated, like especially if you have experience with class React, like the React that we had before hooks, you may have been feeling like all of this additional complexity just isn't worth it and classes were better. Custom hooks are the reason that hooks have kind of pulled ahead in the standard way of doing things in React. So to help me explain why that's the case, we are going to revisit an exercise that we saw earlier for our clock component. And as a quick review, we have a time state variable, it initializes to a new date, and then inside an effect, we run an interval that runs once every second and updates this time so that we see the time updating once per second. And then we have a bit of cleanup logic so that when I toggle this clock away, the interval doesn't run away on its own and run forever. And I'm going to start by converting this to use a custom hook. And to do that, I'm going to give myself some space, create a new function called useTime. And the idea is that I'm going to bundle both of these hooks inside this custom hook. So I'm going to grab this code, paste it in down here. I do get to choose, I can return whatever I want from a custom hook. And the question is, what do I actually need in this markup? Like, what does the component use from all of this work? And the answer is that, well, we need to know the time, right? I need to know the current time because that's what gets rendered. So I'm going to return the time state variable. And in my clock component, I'm going to define time and set it equal to useTime. And just like that, I've reconstructed our clock. Functionally, it's exactly the same. So this code that we have here works exactly as it did when the page loaded. The difference, though, is that I've leveraged a custom hook to tuck this work out of the way. And really, there's two advantages to custom hooks. The first is around code organization, and it's the freedom to structure things however I want. So I can create a hook that holds this stuff, and I can put it below my component, making it easy to see what the component actually does and what it renders. I could even move this into its own file, like maybe I have clockhelpers.js. Really, though, it's the flexibility. Like, we can structure it however we want, which is what's so cool. The second benefit, though, is the really interesting one. With custom hooks, I can share this behavior between components. So if I have some other component on the other side of the application that needs to know what the time is in a way that's always updating, that's tied into React state, and that also is tied into the lifecycle, so the interval stops when the component unmounts, I can use this exact same line of code in any other component to integrate the time, and it can use the time however it likes, whether that's a different sort of visual clock, or maybe it needs it for some business logic purpose, right? It is very, very cool that we're able to share business logic like this with these custom hooks. And you might be thinking, well, couldn't I use a function for that? Like, why does it have to be something special? Functions in JavaScript are the tool for managing shared code. the thing is, we want it to be tightly integrated with React, right? Like, I could have a function that starts an interval, but how would I specify that the interval should stop when the component unmounts? When I look at this code, like, most of this is React stuff. It's not vanilla JavaScript stuff. And so that's what makes custom hooks so special. The ability to package up a bunch of React logic and reuse it between components.
React logic, exactly.
Now there is a rule that we have to follow. Our custom hooks need to start with the word use. And it is a rule that we can bend. Like, everything still works if I name my hook getTime instead of useTime. But React doesn't expect it. And a lot of the tooling, like the ESLint plugins and that, will expect you to start your hooks with the name use.
Exactly.
Remember when we were talking about the rules of hooks? And the first rule is that we're only supposed to use React hooks in a React application setting. Like, I'm not supposed to take a hook and use it in the middle of a JavaScript program. In general, we're only supposed to use them inside components, but the exception there, or at least like the way that they square the circle, is by saying any function can be a custom hook if it starts with the word use. So this is meant to be a very quick introduction. We're going to have plenty of opportunities to build our own hooks and explore this API for ourselves. I hope that you're as excited about it as I am.
Hooks, bro? Okay, do think of this custom hook. Not only that we can organize our code in a function like, but that we can bundle our code into this function. So we can bundle up. So this is two things. We can now bundle up in a function, which makes our code much more easy to organize, right? And also is adding the specific React logic to this to describe a behavior what we want in our application. God damn it. All right, it makes a ton of sense here. That'll be all for this video. Take care. Bye bye.